Next topic is potential energy of system of charges in an external electric field. So in this case the field is already present before we bring the charge due to some charge configuration. So there will be three cases. One, let us take potential energy of a system of charge of a system of a single point charge. Again, let us take axes. Here we have an already electric field which exists due to some charge, let us say placed at origin. It may be uniform or non-uniform. Because of the electric field present in this surroundings, there will be at every point the potential, which is the characteristic of the field. Everywhere we have a potential. Each and every point has a potential. Now, let us suppose that we have a charge Q which is at infinity. Now, we want to bring it, let us say, to a point A, whose position vector is R. Now, due to the electric field produced by some charge, which is either fixed, the condition that the electric field produced by the distribution should be either fixed, or this charge should be, that is the test charge Q should be small. These are the conditions. Small इसलिए होना चाहिए ताकि जो फील्ड यहाँ पर है ये डिस्टर्ब ना हो जाए. अगर ये बड़ा चार्ज है तो E जो प्रोड्यूस करता है इलेक्ट्रिक फील्ड, कोई चार्ज कॉन्फिगरेशन, वो फिक्स्ड होना चाहिए by some force. Okay. Now, when we bring, already here is potential due to this electric field. Let us say that is V. Now, when we bring this test charge Q from infinity to this point, then we have to do the work against this potential or against this field. So that work done, W will be equal to, we already the work done per unit charge is equal to the potential, that is V already here due to this electric field. So W will be equal to QV. This work done will be stored in the potential energy of this charge Q. So this is written as QU or UR, function of R, because potential energy is function of R. अगर यहाँ पर लेंगे तो यहाँ पोटेंशियल एनर्जी का वैल्यू कुछ होगा और ये पोजीशन वेक्टर कुछ होगा. यहाँ लेंगे तो यहाँ कुछ और पोजीशन वेक्टर होगा तो एनर्जी कुछ होगी. तो इसको हम लिखते हैं U is function of R, so it will be UV joules. Now, if this charge happens to be an electron, if the charge happens to be a charge of an electron, हम इलेक्ट्रॉन को ला रहे हैं इन्फिनिटी से यहाँ तक, तो तब एनर्जी क्या होगी? So now we know UR is equal to QV. If Q is the charge of electron, that is 1.6 into 10 raised power minus 19 joules, and V is equal to 1 volt. Then energy U stored in that electron which is brought from infinity will be Q, that is 1.6 into 10 raised power minus 19, sorry, here it is coulomb, into 1 volt. That is 1.6 into 10 raised power minus 19 coulomb volt. That is also called as electron volt. Electron volt. So we define electron volt as the when an electron is brought brought accelerated by a potential of 1 volt, then energy stored will be 1 electron volt. ठीक है, तो 1 electron volt we have seen it is 1.6 into 10 raised power minus 19, that is joule. Coulomb volt means joule. Now bigger unit this is smaller unit. Bigger unit is 1 kilo electron volt, that is 10 raised power 3 electron volt, that will be 1.6 into 10 raised power minus 16 volt, 16 joules. And 1 mega electron volt will be 10 raised power 6 electron volt, which will be 1.6, इसको 3 का बदला देंगे 10 raised power minus 13 joules. And another unit, bigger unit, 1 giga electron volt, that is 10 raised power 9 electron volt, which is equal to 1.6 into 10 raised power minus 10 joule. And another 1 tera electron volt, that is 10 raised power 12 electron volts, which comes out to be 1.6 into 10 raised power minus 7 joules. So 1 electron volt is an energy associated with an electron accelerated through 1 volt. Next, let's talk now. If we have second, इसका हम करेंगे potential energy of 2 point charges in an external electric field E. Again, we draw an axis X, Y, and Z. Electric field, we have an external electric field E, which is in this environment. Now we have two charges Q1 and Q2, which are at infinity. Now we want to bring and arrange them in this electrical field. Now, because of this electric field, there is already a potential. Each and every point there is a specific potential. हर एक point पे अपना potential है because of this field produced by some charge. Now, let us bring Q1 from infinity to this point A, having a position vector R1. Now, because of this, here we have already the potential, let us say VR1, because of this electric field at this point A. Now, work done in bringing this charge Q1 at this point will be product of potential and charge Q1. So, work done in bringing 1, 2 will be equal to VR1 into Q1, because we know that potential is a function of this position. So, we have written as a function of R1. Now we want to bring this Q2, let us say at this point where position vector is R2. ठीक है? This distance is R1. Now, before we bring this Q2 at point B, because of electric field at this point there will be a potential VR2. Because its position vector is R2, so because of this field, so it will be R2. And also there will be a potential at this point because of this charge Q1 which was brought initially. Okay, so total potential at point B will be VR2 plus let us say V1 because of this. So total potential at this will be potential at point B before charge Q2 is brought. Before Q2 is brought at point B is V, which is equal to VR2 plus V1. VR2 I mean function V is a function of this position vector R2. Now V will be equal to VR2 plus V1 will be 1 by 4 pi epsilon 0 as before, Q1 by this distance R12. So work done will be potential into जो चार्ज हम Q2 यहाँ पर लाएंगे. So work done 1 2 is equal to चार्ज हम Q2 लाएंगे, potential V है, so V Q2 V, and we have to substitute this value. Now therefore total work done in arranging this system in external field is given by, so total work done W will be equal to W1 1 2, इसका नाम भी यहाँ पर रखिए W1, सॉरी W1 plus W12, and that will be equal. W1 is already VR1 Q1 V of R1 Q1 plus this Q2 V. Now which is equal to this whole work done is stored as potential energy. We will write as UR. So it will be VR of R1 Q1 plus Q2 and V. This V is here. Substitute the value. So it will be VR2 plus 1 by 4 pi epsilon 0 Q1 by R1. So it will be arranging the terms. So it will be VR1 Q1 plus VR2 Q2 plus 1 by 4 pi epsilon 0 Q1 Q2 R1. This is the potential and is stored in the two charge system which in an electric field E produced by some charge configuration. Next we have third, an electric potential energy of an electric dipole in uniform electric field E. Let us suppose that we have a uniform electric field produced by some charge configuration which we show by the equidistant lines. Let this electric field be E. Let us suppose that we have a dipole, minus Q charge and plus Q charge. Center will be O. Its dipole moment, let us say P. Its length A and A, that is 2A. Now, when we bring this dipole or arrange this dipole in this electric field E, then there will be a force acting on this, that will be a charge Q, that will be plus Q, that will be plus QE. Here it will be force will be F, this charge will because of the electric field it will experience a force charge, that will be Q, minus Q, that will be minus QE. So net force acting on this dipole will be F net, F plus Q plus F minus Q, that will be equal to QE minus QE, that is equal to 0 or 0 vector. So there will be no net force, it will be 0. But because of these two anti-parallel vectors at forces acting, one acting in this direction, other acting this direction, will try to rotate this, and hence there will act a torque. This torque will be in clockwise direction, in pointing inwards. Okay. Now the torque has to do the work. Rotational work will be done. What torque का काम ये है कि इसको या तो इस डायपोल को पैरेलल इसके फील्ड में लाए या इसके एंटी पैरेलल. So this torque tries to align the dipole in the direction of the field parallel to it or anti-parallel to it. Now as the torque acts on it, that is the rotational force. So it will do the rotational work. As we know, the work done, linear work done, F is equal to force into displacement. Work done, W, force into displacement. लेकिन यहाँ पर force 0 है, ठीक है. So यहाँ पर 0 force है. So यहाँ कौन सा force है? This rotational force. That is written as torque. ठीक है. So torque is equal to, that is already we know, P cross E. ठीक है. Let us suppose that this angle is theta. Therefore, tau is equal to magnitude is called PE sin theta. Okay. Let us suppose that at any time a small work done in rotating a dipole from through a small angle d theta will be equal to dw, which is equal to tau into d theta. Okay. So total work done in bringing this dipole or in rotating this dipole through an angle theta 0 to initial position to some final position theta 1 will be given by integrating this whole thing. Okay, so it will be W work done will be integral dW between theta 0 to theta 1. So this will be equal to W will be equal to integral tau d theta between theta 0 to theta 1. This work done will be stored as a potential energy of the dipole. Okay, it is written as theta. Okay, now we will substitute the value of tau. So theta 0, theta 1, that is torque, that is equal to PE sin theta d theta. Now P is constant and E is constant, can be taken outside this integral. Here then we are left with sin theta d theta, theta 0 to theta 1. Now integration of sin theta is minus cos theta between the limits theta 0 to theta 1. Taking this minus out, it will be minus PE. So giving this limit, so it will be cos of theta 1 minus cos of theta 0. Minus अंदर ले जाएंगे, so it will be PE, that will be cos theta 0 minus cos theta 1. That will be U theta. Now here potential energy, जैसे हम मैकेनिक्स में पोटेंशियल एनर्जी ग्राउंड पे लेते हैं 0, ठीक है ना, ग्राउंड पे लेते हैं 0, वो हमारी चॉइस है. हम किसी भी जगह पोटेंशियल एनर्जी 0 ले सकते हैं. मिसाल ग्राउंड से ऊपर किसी जगह पोटेंशियल 0 हम मान सकते हैं, ये रेफरेंस होती है. इसी तरह से यहाँ पर भी जो डायपोल होता है, इसकी कहाँ पर पोटेंशियल एनर्जी हम 0 लेंगे, ठीक है ना. तो वो चॉइस है एट टेकिंग थीटा इक्वल टू π/2 y. देखिए, अगर हम ये जो डायपोल है, अगर हम डायपोल को अरेंज करना चाहते हैं, मिसाल के तौर पर यहाँ दिखाऊंगा, ये यहाँ फील्ड है. डायपोल बनाने के लिए मुझे प्लस क्यू भी लाना पड़ेगा और माइनस क्यू भी. अगर मैंने प्लस क्यू यहाँ पर लाया तो यहाँ पर इसकी वजह से कुछ पोटेंशियल होगी, जो फील्ड होगा उसकी वजह से कुछ पोटेंशियल होगी. लेट अस से एट दिस पॉइंट इट विल बी वी. नाउ सो व्हाट विल वर्क डन, क्यू इनटू वी. ठीक, तो मैंने चार्ज यहाँ पर लाया, वर्क डन हो गया क्यू वी. फिर माइनस क्यू को यहाँ लाया, ठीक है, फील्ड इस डायरेक्शन में, ये याद रखें. तो जब मैंने ये लाया तो इसको वर्क डन कितना होगा, चार्ज इतना है और यहाँ पर पोटेंशियल सेम होगा। क्यों? ये यूनिफॉर्म फील्ड है, इसके अपोजिट हमने जो लाया एग्जैक्टली सेम होगा V, तो वर्क डन विल बी माइनस QV। सो टोटल वर्क डन विल बी QV minus QV, that will be equal to 0. So it is the obvious choice. तो ये एंगल क्या बनेगा यहाँ पर 90 डिग्री बनेगा, E इस डायरेक्शन में E. So in arranging a dipole perpendicular to the electric field, energy required is 0. So we take angle theta is equal to pi by 2. So when we substitute in this, so U theta will be equal to PE cos of pi by 2, और ये कोई जनरल एंगल लेंगे हम cos थीटा, उन्हें पाई बाई 2 से कोई एंगल तक इसको ले जाने में, ठीक है। सो cos pi by 2 is equal to 0, so it will be u theta will be equal to 0 minus cos theta, that will minus P is equal to minus PE cos theta, which can be written as u theta is equal to minus P dot E, because AB cos theta is equal to AB cos theta is equal to AB P dot E. PE cos theta is equal to P dot E. Okay. Now, 3 cases arise here. First of all, we have U theta is equal to minus PE cos of theta. Now, if theta is equal to pi by 2, then cos pi by 2 is equal to 0. Therefore, U theta is equal to 0. So, at this stage, we say that dipole is in stable neutral equilibrium. ठीक, यहाँ न्यूट्रल इक्विलिब्रियम में है, यानी अगर फील्ड हम लगाएंगे तो ये जो डाइपोल है या तो यहाँ पैरेलल भी हो सकता है या एंटी पैरेलल भी हो सकता है, ठीक, दोनों चांसेस है यहाँ पर। अब when theta is equal to 0 degree, then u theta या u 0 degree, यहाँ पाई बाई 2 लिखूंगा मैं, u 0 degree will be equal to, क्योंकि cos 0 1 होता है, it will be minus P. This is minimum energy. इस डायरेक्शन में, जब डायपोल हमारा इस डायरेक्शन में होगा ऐसे, ठीक है, तो मिनिमम एनर्जी, तो ये स्टेबल इक्विलिब्रियम, we say dipole is in stable equilibrium. Now, स्टेबल इक्विलिब्रियम उसका मतलब, अच्छा यहाँ पर एक बात नोट करो, 0 एनर्जी यहाँ पर है पाई बाई 2 जब एंगल होता है, यहाँ माइनस पी, इसका मतलब यहाँ डायपोल में एनर्जी होती, बिकॉज 0 इज ग्रेटर देन माइनस, मिसाल माइनस 1 इज ग्रेटर देन माइनस 1 इज ग्रेटर देन माइनस 1, सिमिलरली 0 इज ग्रेटर देन माइनस 1, इसी तरह से माइनस पी ई इज ग्रेटर देन 0 पी, ठीक है, 0 p means 0, so 0 is greater than, so energy of a dipole when it is at 90 is more than when it is in the direction of the electric field. Also, if theta is pi, ठीक, cos pi is minus 1, ठीक, तो जब -1 है तो it means energy will be equal to -1 into -1, that is plus 1 P. So energy here is maximum. We say that dipole is unstable. Dipole is in unstable equilibrium, and it will try to align back in this direction. जब इस डायरेक्शन में होगा तो स्टेबल होगा, तो रहेगा इसी में, जब ऐसे होगा तो यहाँ पर क्या होगा, इस पोजीशन में होगा, ये न्यूट्रल यहाँ पर भी जा सकता है और इस डायरेक्शन में जा सकता है, और जब यहाँ पर हो तो ये अनस्टेबल होगी, इसकी एनर्जी मैक्सिमम होगी, एवरीथिंग ट्राइज टू बी इन दिस मिनिमम स्टेट ऑफ एनर्जी, सो इट विल ट्राई टू ऑसिलेट एंड कम बैक टू, if free to do so, it will try to be in this direction. Okay, thank you.